We all use this incredible digital infrastructure literally every single day. Think about your phone or the cloud services powering everything. But underneath all those apps and websites, there's usually an operating system making it all work. Today, we're doing a deep dive into the really remarkable story behind one of the most important ones, GNU Linux. We've gathered insights from various places, academic papers, historical summaries, just to piece together how it went from a research idea to, well, this global tech backbone. Our mission here is to quickly unpack the key moments, maybe some surprising facts, that made GNU Linux what it is, basically a shortcut for you to grasp its huge impact. So where do we even begin this story? Okay, so before we even get to GNU or Linux, there was this foundational system, right, developed back at Bell Labs.
That's right. Yeah, we're talking late 60s, early 70s. Bell Labs, which was AT&T's research arm back then, and two key figures, Ken Thompson and Dennis Ritchie, they developed Unix.
And Unix wasn't just another OS, was it? It brought some really new ideas to the table.
Oh, absolutely groundbreaking for the time. Things that we kind of take for granted now.
What specifically? What made it stand out?
Well, first off, its portability. I mean, that was huge.
Meaning it could run on different computers.
Exactly. Before Unix, systems were mostly tied to one specific type of hardware. Unix could be adapted with, relatively little effort. That's why it spread so quickly.
Okay, portability. What else?
Then there was multi-user capability.
Right. Multiple people using one machine at the same time.
Yeah, through separate terminals, all working independently. And also, multitasking the system could juggle multiple programs, multiple processes simultaneously.
Which boosted productivity, I imagine.
Dramatically. It just opened up completely new ways of using computers. And what's really fascinating, looking back, is how those core concepts, portability, multi-user, multitasking, they didn't just define Unix. They pretty much laid the blueprint for almost every major operating system that came after, including GNU Linux, of course.
So understanding Unix is kind of essential background.
Definitely. It helps you grasp the whole philosophy, the architecture behind these modern systems. It really did set the stage.
Okay, so Unix is spreading, it's influential, but it was proprietary, right? AT&T owned it.
It was, and that started to become a point of friction for some people in the computing community.
Which leads us to the next major chapter, I suppose, the GNU project.
Exactly. This is where the story takes a really interesting turn, both philosophically and technically.
So, 1984. Tell us about Richard Stallman and the GNU project.
Right. Richard Stallman, a programmer at MIT's AI lab at the time, and a very strong advocate for software freedom. He launched the GNU project with a really bold goal: create an entire operating system that was completely free.
And free here meant more than just zero cost, didn't it?
Oh, much more. It was about liberty. The freedom for users to run the software for any purpose, to study how it works, to modify it, and crucially, to share those modifications, free from the restrictions of proprietary licenses.
And the name, GNU.
Ah, yes, the name. It's a recursive acronym, stands for GNU's Not Unix.
Hey, okay. A bit playful.
Yeah, it signaled that it was designed to be Unix-compatible, Unix-like, but fundamentally different because it was entirely free software.
So Stallman has this vision. How do you actually guarantee software stays free once it's out there? Couldn't a company just take it and lock it down?
That was the critical question, and Stallman's answer was ingenious. The GNU General Public License, the GPL.
The GPL. Okay, what did that do?
Well, the GPL legally grants all those freedoms we just talked about: run, study, modify, share. But it has this key mechanism, often called copyleft.
Copyleft, as opposed to copyright.
Exactly. Copyleft uses copyright law, but flips it. It says, yes, you can modify and distribute the software, but any derivative work you create must also be licensed under the same GPL terms.
Ah, so it ensures the freedom travels with the code. You can't make a proprietary version from GPL code.
Precisely. It prevents free software from being turned into closed-source proprietary software down the line. It became incredibly important, one of the most widely used licenses for free software.
So the GNU project wasn't just philosophy and licenses. They were actually building software components too, right?
Absolutely. They needed the actual tools to make a usable system.
Yeah.
And they created some incredibly important ones.
Like what? What are the core GNU tools?
Well, there's GCC, the GNU Compiler Collection, essential for compiling source code into programs.
Okay, the compiler.
Then you've got Bash, the GNU Born-Again shell. That's the command line, the interface many people use to interact with the system, incredibly powerful for scripting.
Right. Bash is everywhere.
And also things like Cortels, the basic file manipulation tools, text utilities, Ls, cp, mv, all that stuff. The fundamental commands.
So even before Linux itself existed, GNU had built a lot of the essential pieces of a Unix-like operating system.
That's exactly right. They had created this robust set of tools, the compiler, the shell, the core utilities, forming the backbone, the sort of user land of the system. It was a powerful free software environment, just waiting for one crucial component.
The kernel.
The kernel, the core part that actually talks to the hardware.
And that piece arrives somewhat unexpectedly in 1991 from Finland.
Yeah, quite serendipitously. Linus Torvalds, a student at the University of Helsinki.
Just a student project initially.
Pretty much. He was inspired by Unix, specifically a teaching version called Minix, but he wanted to build his own kernel, something free and open source that could run on the standard PCs becoming common then.
And the kernel, just to clarify for everyone, that's the absolute core, managing hardware, letting software run.
Exactly. It's the traffic cop, the resource manager, the engine right at the heart of the OS.
Now, Torvalds didn't just build this in isolation, did he? His approach was different.
Very different and incredibly important. He announced his little project on Usenet. Think of it as an early online forum.
Okay.
And he explicitly asked for help. He put the code out there and invited people to contribute, to test it, to suggest improvements.
So open collaboration right from the start.
Right from the very beginning. And that model was revolutionary. People jumped in, hobbyists, other students, professional developers from all over the world. The development pace was just astonishing because of this global collaborative effort.
Wow. Okay, so Torvalds creates this kernel, Linux, and the GNU project already has all these tools.
Exactly. You see where this is going. The Linux kernel, brilliant as it was really just that, a kernel. The real magic happened when people realized you could take this new, freely available Linux kernel and combine it with the existing, mature, and also free GNU toolset.
The two halves coming together.
Precisely. The Linux kernel managing the hardware and the GNU compilers, shell, and utilities, providing the user environment and the tools to build more software. That combination created a complete, functional, free, and open source operating system.
And that combination is what we typically call GNULix, or often just Linux colloquially.
Correct. Though the naming is sometimes debated, understanding that it's this synergy, the GNU project's components plus the Linux kernel, is absolutely key. It wasn't just one person or one project. It was this powerful fusion.
So we have this functional free OS. How does it go from, a thing for hobbyists and academics to, well, powering huge parts of the internet and more?
Yeah, that's the next big leap. It needed to become easier to install and use for people who weren't deep sea programmers or kernel hackers.
Right.
And that's where distributions or distros came in, mostly starting in the early to mid-90s.
What did these distributions do?
Companies and community groups started packaging the Linux kernel together with the GNU tools, plus installation programs, maybe a graphical interface setup, package management systems to easily add more software. Basically, creating a complete installable package.
Making it more user-friendly.
Exactly. And different groups had different focuses. You had companies like Red Hat emerge, really targeting businesses and servers.
Okay, the enterprise angle.
SUSE became very strong, particularly in Europe. And then you had community projects like Debian, fiercely committed to free software principles and known for its stability.
So different flavors started appearing, catering to different needs.
Right. And this coincided with the explosion of the internet. Businesses needed reliable, affordable servers to host websites and online services.
And GNU Linux fit the bill.
Perfectly. It was stable, it was secure, you could tweak it endlessly because the source code was available. And crucially, it didn't have the high licensing costs of proprietary Unix or Windows server systems.
So it just took off in the server world.
It absolutely dominated. Web servers, file servers, databases. Its reliability and low cost, combined with that open model allowing for rapid fixes and adaptation, made it the go-to choice. It really became the backbone of the growing internet infrastructure.
And that flexibility, that open model, it seems like that's still its strength today, right?
Yeah.
Where else do we see GNU Linux now?
Oh, it's everywhere. I mean, cloud computing, it's almost entirely built on Linux. Virtual machines, containers, orchestration tools like Kubernetes, predominantly Linux-based.
Right, the cloud runs on it.
Then there's embedded systems, your home router, smart TVs, in-car systems, industrial controllers. Countless devices run some form of Linux because it's adaptable and can be trimmed down to run efficiently on less powerful hardware.
Stuff you don't even think about.
Exactly. And of course on the desktop too. While it doesn't have the market share of Windows or macOS, there are many user-friendly distributions like Ubuntu or Fedora that make it a really viable, powerful option for everyday computing.
So its influence just kept expanding from servers into, well, pretty much every corner of technology.
It really did. That flexibility, the security focus born from its open development, and the sheer power of collaborative innovation. It continues to drive tech forward globally.
What an incredible arc. From the academic roots of Unix at Bell Labs
Hmm.
through Stallman's really powerful vision for software freedom with the GNU project and its tools,
Yeah, the essential userland.
then Linus Torvalds kernel, born from a student project and open collaboration,
The missing piece.
creating GNU Linux, and then its journey into commercial viability, dominating servers, powering the cloud, embedded devices, and desktops. It's quite a story.
That really is remarkable.
Thinking about this whole journey,
Mm.
the way this incredibly critical piece of global infrastructure was built through collaboration, through an open source spirit, it makes you wonder, doesn't it? Given how successful that model was for GNU Linux, what other really crucial technologies in our lives, perhaps things we rely on every day, could seriously benefit from that same kind of open development and community contribution? Something to think about.